All right, ladies and gentlemen, hello and welcome back once again to the longest running show in the world about data. It's called DM Radio. Yes, indeed, we're rocking and rolling here. We're going to turn 17 years old in February. We're like late teenagers, man. So we're getting in trouble. And today, I'm very pleased to have with me one of the legends of the big data era, Amar Awadallah, who is now with a company called Vectara. You may recognize him from the Cloudera days. They were, of course, the juggernaut that really took big data into the mainstream.
Mhm.
And now he's focused, guess what, on the next big thing, large language models and vector databases and similarity searches and how to tame the large language models. And I think that's probably the most fascinating aspect of them. And in a recent show we did, in fact, I did a recording for part of it today. I pointed out to people to remember that these foundational models, Gemini, ChatGPT, Claude, they are all probabilistic in nature, which means they are not deterministic. So when you do a query from a database, it's deterministic. It'll show you what is in that database. And if it's wrong, that's because someone entered it wrong or did the equation wrong or something. But the old-fashioned database gives you what you asked it for, specifically, discretely, exactly as it is. That's not what these engines do. They are probabilistic and they are generative. And I actually once had the go-to-market guy for ChatGPT on a Twitter thread, and I asked him, "Hey, what are you going to do about these hallucinations?" And he said, "Remember, they're more of a feature than a bug." So these systems are designed to generate text based upon prompt and upon their training. And as I've mentioned in other shows, what you do when you train these models is you take text, you convert them into vectors, and then when you ask it a question, it takes the vectors and it converts it back to text. That's why it's a bit of a lossy process. That's why they're a bit loosey-goosey on stuff, especially that's fringe. Now, something that's mainstream that has been widely published about, they're going to be pretty good because there's enough information out there. And when you get right down to it, they are consensus engines. That's really what they're doing is giving you the consensus of their knowledge, of their training about a particular topic. And that can be very useful, but they're wrong, 10 to 20% of the time. So I ask people, what part of your business can be wrong 20% of the time? Fulfillment, operations, accounting, sales? No. I mean, imagine if every time you bought a product from Amazon, there was a 20% chance you get the wrong product. You wouldn't buy from Amazon very much anymore. That would be over. But you're gonna see these hybrid searches in other ways, and RAG, retrieval augmented generation, is all about grounding the large language models, shepherding or controlling what they deliver to make it more accurate. And with that, let's bring in Amr Awadallah of Victara. Tell us, what's this new company all about? What are you guys doing?
I think you gave actually a good description of I wasn't going to say it that way, but I like what you said. It's about taming the beast.
Right.
How do
That's
you
right.
tame the large language models so that they can be used within a business environment? And this is really what we're about, right? So we're about helping businesses building very reliable, we call them enterprise ready AI assistants and AI agents that do three things, which are the three problems that we have with large language models. The first one is to be accurate, so to not make up stuff. The second one is to be secure, meaning to not leak stuff. So as you might know, these models are susceptible to what's called a prompt attack, where you can get them to reveal things to you that you should not be seeing. And that can be, of course, very, very damaging in a business construct. And then the last thing that we specialize in is explainability. So getting these models to explain how they came up with their conclusion. That explainability is required in some industries like finance, legal, accounting. But for all industries, I always like to say if you cannot measure it, you cannot fix it. If you
Right.
cannot see how the AI assistant came up with his response and what it depended on to deduce this response, then how are you going to correct it in the future to give the right
Right.
response? So
Right.
observability and explainability is a must, in my humble opinion. And that's what we do. So it's about taming the beast.
Yeah, so let's get into the weeds about how that's done,
Yeah.
because there are many ways that you can do this. There are lots of companies talking about this. There's a company, Ops and Security, I've interviewed. There's another company that's building Eidolon, which is an interesting way of dealing with agents, and these are two arguably separate conversations, right? AI
Yeah.
agents versus
Yes.
large language models. You can use them you can use agents for language models, et cetera. But let's talk about the language models first and being able to tame them. What
Yes.
what have you built to enable that?
Yes. So first, you're right. There's multiple threads in the industry going on right now. They're all related, to be honest. But
Right.
the most active thread right now that all of us are working on is what I like to refer to as AI assistants. And AI assistants are human in the loop systems, right? This is
Mm,
where there is an assistant giving you a response, giving you a recommendation, but the human is still the one that's going to be performing the action based
right.
on that recommendation. And this is really where the industry is right now at large. We're all very, very focused on that right now. The next step, like once we figure out the hallucinations and really eliminate them completely with very, very high confidence, and we trust and we gain trust into these systems more as businesses, then we'll start entering the next phase, which is the AI agents phase. And in the AI agents phase, that's where now we will depend on these systems to not just give us a recommendation or give us a course of action or give us an answer, and then we implement it. No, they're going to go implement it themselves. And they're going to take the actions themselves. So they're going to be read write versus read only, if
Mm.
I might say it that way. So today we're very, very focused on the read only. So how do you fix this hallucination issue? First, I always like to highlight that hallucination is the wrong term. Like,
Hmm.
unfortunately, the media latched onto the
That's right.
term and amplified it because of the relationship
Right.
with the psychedelics and drugs and
Right.
stuff like
It's
that.
tripping. It's tripping.
Yeah. But the father of AI, Jeffrey Hinton, who just won a Nobel Prize a couple of weeks ago, he prefers using the term confabulation.
Mm,
And that's the more accurate term. So what is confabulation? Confabulation, for humans first, confabulation is when we lie, but we lie unintentionally, right?
mm,
Like, so our memory, so we're saying something that's not true, but not because we want to lie, it's because our memory, to the best of its ability, reconstructing the facts and the information, that's what it came up with. Like, I could have met you, Eric, 8 years ago, and we could have talked about the movie The Matrix and how much we love The Matrix. And then I meet you now, and instead I tell you, oh, remember when we talked about Inception and how amazing
right.
Inception is?
Right.
And you'll tell you, yeah, it was a great movie. I love Inception. I remember when we talked about that, and we didn't, right?
Right.
So that's confabulation. So that's kind of what's happening here with these neural networks. Is as they are trying to reconstruct the answers, the memory they have is not a perfect memory. So it's not like a database. The analogy you gave is very, very good. Databases have perfect memory. Databases are storing all the bits as is. They are compressing them, but they're not compressing them too much to lose the fidelity of the information, and hence they're able to recover everything. Neural networks, on the other hand, they're not being trained on all of that data to store it. They're not being trained to be a database. That actually, the fact that they work as databases is a nice side effect that we were
Mm.
surprised by. The reason why we train these neural networks on trillions and trillions of words, we call them tokens, as you know, is to get them to develop a high level understanding of the English language, the French language, and how to compose words and grammar and vocabulary together, to get them to understand the first principles of physics, the first principles of mathematics, the first principles of biology, whatever, so that they can solve problems for us and can summarize documents for us, and that's why we're training them on these big amounts of information. Now, what surprised all of us is, despite how small these models are compared to the amount of data they've been trained on, they're being trained on trillions of words, but the model itself is only billions of parameters.
Mm.
And by the way, every parameter is roughly 2 bits of information, is in every parameter. So you have trillions of words being squished down and compressed to fit only within, sorry, trillions of words being squished down to fit only within billions of parameters. That's a very, very high compression rate. That's like 1,000x compression, right?
Yeah, right.
And if you go back to information theory and the Shannon information theory for the computer scientists among you, or the information theorists among you, you would recall that the maximum theoretical compression based on entropy for a big corpus of text is about 8x. Like, if
Mm.
you go beyond 8x,
Wow.
then you're now crossing from the lossless zone into the lossy zone, right? So
Hmm.
if I take a document that, let's say it's 1,000 words, and I compress it down by 8 times, so how much would that be? Would be like 80 characters, right? Or something like that. Sorry, 120 to 120. So I compress it down from 1,000 to 120. I can go back from this 120 to the 1,000 perfectly, okay? But if I were to compress it beyond that 8x, then there would be gaps in knowledge. So these models, to summarize, these models compress information so severely that they're way beyond that kind of lossless limit. And that's why they have
Interesting.
gaps in their memory, like, to simplify things. This is an
Mm.
analogy here just to make to make it more clear in our heads why these things confabulate or why they have to make up stuff. It's because
Right.
they have gaps in their memory because they're compressing down the information too much. And by the way, it's very impressive to all of us how much they're still able to recall despite that very, very severe compression. So
Hmm.
that's why confabulation happens. So how do you solve it? You solve it in the same way that you solve it for humans. So when we go to school, for example, and study at university, we read many books. We are reading all of these books again for the same purpose as a large language model. We're reading them not to remember every word in every book. Like when you're studying
Right.
at university, your goal
Right.
is not to remember every word in every book. Your goal is to extract all of these words into the first principles that give you the understanding of biology, of physics, of history, etc., etc. This is really what you're training on. Now you're taking a multiple choice exam in high school, and you want to be an A+ student. Uh, what do you do when you see 100 questions and there's 10 questions that you can't remember the answer for? You guess. You still, to the best of your ability, say, I think it's this one. To the best of my memory, I think it's going to be this one. It's going to be that one. So it means that you are relying on your imperfect memory to still solve all of the questions because you want to get a big grade. And every multiple choice question you answer, you maximize your grade. So that's when you're at high school or university. But when you finish that now and go to work, and now you're a doctor in a hospital and you're diagnosing a patient, and you can't remember the diagnosis for a specific disease, do you still rely on your memory? You do, but then if you find it's not perfect, you open the book. You open the
Right.
book that has the diagnosis, or you do a search in some of your systems. So we call that open book machine learning. And actually, that's the technical
Hmm.
term. We call it open book machine learning versus closed book. So closed book is asking the large language model to remember everything in its model, which is impossible given how much
Hmm.
we compress information. Uh, Open book is rely on the large language model to understand everything, but then during runtime, when it's actually answering a question, refresh its memory. Give it the facts. These are the facts underlying this question that you have right now. And then we tell the large language model, use these facts to answer the question. So that open book technique is what significantly reduces the probability of hallucinations. That's number one. There's three things that we do. So
Yeah.
the first one is open book. Any questions on that, Eric?
Yeah, well, that's so now you're talking about the summarization capability of the large language models where you load a document into it and then ask it questions about that document, and that's within a certain context window,
Yes,
right? This is one of the keys to remember with these models is they have a context window, just like people have. There's
yeah,
only so much context you can pull into your brain at any given point in time. Understanding that you can then dig into other contexts as you're talking to someone, right? Because things remind you of things. Like I've learned that my memory is very associative. So you mentioned a couple movies. I'll be like, what was that movie called? Oh, wait, I know that Kevin Bacon was in it, and I know that this person was in it. So it's like you're almost it's like a graph where you're making
yeah,
hops in the graph to get to the memory that you had. Like, oh, that's right, it was this movie XYZ. Right.
exactly,
So that's kind of what you're talking about, the summarization capacity and citation. And I think you're
exactly,
right that the answer to the hallucinations, the answer to training these better and better, whether it's fine tuning or in your RAG model or whatever, is the citation to say, this is the what I say, and this is where I got that information, right?
exactly. So that's step number one. So step number one is doing that. What we just you eloquently summarized my long spiel on it
It's all right.
is to make sure that we refresh the context in real time by giving the LLM clues about what's going on and needles and key facts about what's going on. So when it's answering that question, it's now more accurate because
Hmm.
you refreshed it in runtime and not just during training time. However, another thing needs to be done, which to get these systems to be more accurate, which is to train the large language model in a different way. So most large language models today, the cost function or the reward function that we reward them on is to try and answer all questions. Like if you look at Llama or GPT, they have been trained on try to be a know-it-all. Like you're gonna be a
Hmm.
know-it-all. You want to get the highest grade in that multiple choice question you're getting in high school. If you don't know something, still answer it, even if it's a bit off, so you can get a good grade, right? So the reward function is answer everything, even if you're not sure. To use it in a business concept, business context, you need to change that reward function. So in a business context, you need to have a large language model that is more incentivized to only answer when it's sure. So what
Hmm.
you want to do is penalize it for the wrong answers. So we do a training cycle, an optimization cycle on top of the LLM to significantly reduce the probability that it's gonna say something where it's not confident of the response. So that's the second thing that you need to do. And it's very similar again to how if a doctor is taking a high school exam and he just wants to get a high grade on his exam, he's going to answer everything, even if he has to guess. But then in a medical situation where he's treating an actual patient, if he's unsure, he's going to say, no, I'm not sure. I'm not going to answer this question right now. Right? So it's kind of the same kind of analogy there. So that's the second thing you need to do. Do you want to reflect on that one?
Yeah. So that's very interesting. I'm curious to know where in the process that's done, right?
Fine
Because
tuning,
it
fine
what's
tuning.
interesting is you give it a prompt and you can tell if it's a very complicated one, it thinks and thinks and thinks and thinks, then boom, it spits out its answer,
Yeah.
right? And I've believed for a while now that you're going to have additional layers built into these models to facilitate, for example, like you're suggesting, ontologies, a lexicon, for example, a vertical specific ontology. In fact, there are some companies we worked with, like Praxi Data is one. Oh, there's another one that's doing something similar where you give it an ontology, so you're giving it a framework within which to operate
Mhm.
and helping it train to focus on only answers that are meaningful for you. And that then you're hearing about small language models too, right? And there's also a couple different things you can do. You can do a RAG model where you have your vector database that you populate with your information, or you can fine tune the model, which I think is probably more complex. Like,
Yes.
yes, you can do it, but you're basically embedding another layer. And we'll dig into more of this in the second segment, folks. The first break is coming up here. But these are different ways to do it. And there are pros and cons to all these things. But I think you're really onto something, that you have this three-step process. It's not just a one thing, it's
Yeah.
one thing, a second thing, a third thing. We'll pick that up in the next segment here, folks. We're talking to Amr Awadallah. He is now the founder, I believe, of
Yes.
Vectara,
Founder and
former
CEO.
CTO and co-founder of Cloudera, which is still
Right.
around. Of course, Cloudera didn't go away.
Mhm.
They're still out there along with Hortonworks. They kind of
Mhm.
fused into one
Yeah.
company. And I remember the whole story. I was there. I covered it quite closely. It's an amazing journey that we're on now, but I love seeing that you're focused on this new wave of innovation, which is where all the energy is going, and rightly so. We'll be right back. You're listening to DM Radio. All right, folks, welcome back to DM Radio, a very special show talking to Amr Awadallah. He's the founder of a new company called Vectara, formerly of Cloudera. So he's a big data guy. And now you're getting into semantics and large language models. And I saw you smile when I mentioned ontologies. So, you get all that stuff. And we're trying to shepherd these amazing large language models. They are like very powerful camels, but they'll just run all over the place if you're not
Mhm.
careful with them. You got to get them to do what you want them to do. So
Mhm.
you were talking about the first step and then the second step. And I
Yeah.
like the second step. It's very interesting. And I'm very keen to understand where it comes into play. It's like a reminder as the answer is being given, and also citations, right? So where did you get this information? You said I have to do XYZ. We got it from here, we got it from there, paragraph 2, paragraph 17, that kind of thing, right? Go ahead.
Exactly. So that happens during the second step. Before I jump into explaining second step, I mean, again, we're covering very complex stuff here in a very short period of time. So I just wanted to let your audience know we actually have an event tomorrow, Friday. Sorry,
Ah,
tomorrow. Yes, Friday.
yeah.
And isn't
Washington,
tomorrow Friday,
D.C.
right?
Yeah. Tomorrow's
Yeah,
Friday.
yeah,
Yeah.
yeah, yeah. I apologize. Just like I've
Time
been
flies
traveling
when you're
so
having
much the
fun.
last couple of days, so I'm kind of. So tomorrow, Friday, in Reston, in DC, where we'll be covering this in a lot more detail. It's an event called RAG on the Road. Though I love Eric at the beginning, you said we should change this name to be Road Rag, which I love that. So maybe next time we'll do it that way.
Very
But
good.
I invite those of you that would like to learn more about the details. We're going to cover all of that and show demos of all of these things in action. So if you're
Nice.
curious to learn more, I highly recommend you try and attend that event. But here, to refresh your memory briefly, in the first segment, we covered the first technique, which is open book machine learning versus closed book, which is about refreshing the context of the large language model during runtime with the key facts relevant to the question or task that you are asking, so that the large language model refreshes its memory and is more likely to not make up stuff. So that's step number one. Step number two, and that we discussed during the first segment, is to change the reward function for the model,
All right.
that we reward you for correct answers and we penalize you for incorrect answers. So that's done during fine-tuning stage, Eric. So that's during the model building stage. So after we finish building the model, we take that model through a fine-tuning stage where we do a reinforcement feedback to the model, and we encourage it whenever it's answering something right to give it extra points and say, yes, you're doing very well right now. Whenever it's answers something wrong, we give it a thumbs up and say, no, 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 don't do that again. This is a bad answer. Don't be a know-it-all. Don't try to answer every question. If you don't know the answer, just say I don't know versus give me a made-up answer. And that fine-tuning process, which happens during training time, is now what prepares this model to be a lot more accurate and less likely to make up stuff during runtime. At the same time, when we're doing that training, we also reward the model whenever it correctly cites the sources that it depended on to come up with that answer. So that further improves its explainability of how it came up with the response. So does that make sense to you?
Yeah, and so when you talk about penalizing and rewarding,
Yeah.
what is that like in terms of computation? What is that like in terms of training? Like what function goes in there and says this was bad or this was good? How does the model absorb that is the question I'm asking.
Yeah, that goes back to how we train any neural network. So whenever we're training any neural network, it has a number of outputs. And during the training phase, we're comparing these outputs to the intended behavior. And every time the neural network is matching up with the intended behavior, we give it positive feedback that you are doing well right now, keep doing that. And whenever it's not, we give it negative feedback.
Hmm.
Very similar to how we train humans, actually. And
Yeah.
that's the underlying principle for how neural networks are built.
I'm going to throw an interesting comment at you I had from a gentleman on the show probably like 7 or 8 years ago. So
Uh-huh.
earlier, much earlier in this era of training models. And he was talking about reinforcement learning and having people sit there and give answers just like you're talking about.
Yeah,
Is this a muffin? Is this a dog? Is this a
yeah,
muffin? Is this a dog? And
yeah.
what he told me was very interesting. He said, from their research, and this is his whole area of expertise, do you guess which percentage of people are good at that task, are really good and honest about getting it right? He said
You
it's
are right. Yes.
4%.
Yes,
He
I
said
believe that.
4. It's like, oh no, that's not very good. So it's
Yes.
like even people are bad. I mean, that's one of the
Yeah.
things about, we worry about these models getting things wrong. Well, people get stuff wrong all the freaking
Yes.
time.
Yes. That's why
It's a,
when we do this, we actually have multiple people. When we do this real reinforcement learning with human
oh,
feedback,
that's
there is
clever.
more than one human because for the same question, because we don't trust that single human to get it right. We want to get the consensus across them. So you're
Right.
absolutely right.
That's
Even
beautiful.
even we are bad
Consensus
at that.
engines. Yeah,
Yes.
there. All right, go ahead. Go ahead.
So the third thing, so we covered the first thing. So the first thing is open book versus closed book. So open book helps a lot. The second thing is uh, train the model to be only respond when it's sure versus always respond versus being a know-it-all. And then the third thing, which is also even true for human beings as well, if you have a doctor making a very important decision or a lawyer publishing a very important legal draft, or even a press in media when they're publishing a news article, they're always worried that that reporter or that lawyer or that doctor confabulated something or made up something. So what do? They have a fact checker. They have a second opinion. They have somebody that looks at the output of that lawyer. So the third thing that we do in our pipeline to mitigate hallucination significantly is we have a separate model from the main large language model that reads the response in real time. So it reads that response that came back, that summary, that answer that came back. It reads it from the large language model, compares it to the underlying needles, the facts that were provided in the context window, and then gives you a score. This response is 100% perfect. It did not deviate from any of the facts. It's good. You can rely on it. Versus, oh, this response has a couple of things that are off a bit. Versus, this response is horrible. You should throw it away. This is really bad. You'll get in trouble if you use this right now. So that model is called the Hughes hallucination evaluation model. It's actually the number one. That model is open source. We open source that model. It's the number one open source model for hallucination on Hugging Face. If you go to Hugging Face right now
Wow.
and just
Yeah,
search
right.
for hallucination, you'll find that almost 3 million downloads of that model right now.
Wow. That's
Yeah.
cool. There's a company, Darwin AI, out of Canada somewhere. Have you ever come across those guys? So
No, I have
what they
not.
do, I thought was very interesting. A few years ago now, but what they would do is they came up with a model to help you understand how neural networks were doing things. So it sounds like you've created something similar to what they would do, and basically it would look at the outputs and it'd
Yes.
say, would think, how did they get to this? There's a famous
Yes.
story about, my dog is barking here. There's a famous story about for self-driving cars, they had all kind of problems in the rain, and they realized, oh, this like they weren't in the rain when we recorded this stuff, and so just the water bouncing off the cars was throwing
Yeah.
off the engine. That's the kind of thing you can catch with this engine you're talking about, right?
Yeah, yeah, yeah. I mean, of course, we don't do it for images and videos, which is what you need in the car scenario. We're doing it mainly for text, but exactly. So essentially, what the model is doing is it's assessing for that task of when you give the large language model a prompt that says, "Please answer this question." And then here are all the underlying facts that we think are related to this question. And then the model now creates that response for the question, depending on all of these facts. It's comparing that response back to that context window that had all the facts and assessing how honest you were in summarizing and coalescing these facts together into a cohesive response. So that's kind of the specific description of what we're doing here at this step. So this combination of these three things, open book, which is RAG, really open book is another way of saying RAG. Second, models that are optimized to be accurate versus to be know-it-alls. And third, fact checkers that are running in real time. So some people have fact checkers that run during training time. No, we're talking about fact checker that is running in real time with every answer coming back from the model and making sure that that answer is not deviating from the facts. That's how you bring down hallucination significantly.
Yeah, and
That said,
this is very encouraging for me because I remember thinking about all this stuff a while ago. I said, you know what you're going to need to do is you're going to need to do the things you mentioned, and especially that third step. I said you're going to
yeah,
need to have a different model that checks this. So as the answer is coming back, it's like, hold on a second, let me run this through a it's called QA, right?
yeah,
Quality assurance. I have a
exactly.
quality assurance model to
Yeah,
say, are you guys sure that this is correct? And check it. Okay, let it out the door. And that's exactly what you've
exactly.
done, right?
Exactly. And by the way, going back to your 4% comment about humans being fooled in the task of even recognizing objects and answering questions and so on, for hallucination and detecting whether a response is hallucinated or not, humans are actually bad at that as well. Like
Yeah,
humans frequently will look at the response, it's like, wow, that looks correct, that's perfect, and it's completely wrong.
right.
Because even we are not very good at doing that, at detecting hallucination when it's taking place. Yeah.
Yeah, well, as a side note, I gave a talk earlier this year. It was my debut at the Javits Center on the death of journalism, and what I meant by that was that, and I can talk all about this all day,
Oh, please do.
is that much of what passes for journalism these days is really narrative-driven
Yep,
cherry picking.
yep.
So there's a narrative they're trying to push. They find little bits and pieces that fill that narrative. That's called overfitting the model, basically,
Yep,
right? In the ML
exactly.
world.
You're right.
And I
Yeah,
say this is a real problem, folks,
yeah,
because you're not getting the real information that you need to make good decisions.
yeah,
And so overfitting narratives is no bueno.
yeah,
Like,
yeah, yeah. And sometimes humans do it not because intentionally. They do it just because they were biased.
well,
They were biased
right.
in their education in some way
That
or biased in their, yeah,
that's right. Or politically. I mean, you
yeah,
mentioned, a certain politician at the top of the hour.
yeah.
And so in my research for this talk, I mean, the facts just jumped out and hit me in the face, quite frankly. And one of the things I came across that blew my mind
Hmm.
was that 40 some percent of Americans now have trouble distinguishing between a fact and an opinion.
Oh
I'm
my
thinking to
God.
myself, holy Christmas, I learned
Oh
that
my
in the
God.
second grade. In the second grade, I learned Coca-Cola is tasty is an opinion. I have a Coca-Cola is a fact. Okay. These are
Yeah,
different things.
yeah, yeah,
But to your point, like understanding hallucinations, people,
yeah,
we don't know everything. And so we
yeah,
get stuff wrong. And it's good to have a little fact checker behind you. Go, oh,
exactly.
actually, this was this and this was that.
Yeah,
And don't be offended by that. That's what I love about these large language models. They're not offended. Like, no, that's wrong. It is, oh, I'm sorry. Here's the new
yeah,
answer. It just kind of
yeah, yeah,
gives you right.
yeah,
So, but this is very, very cool stuff. I'm impressed with the architecture. So let's talk about how it actually deploys. So
yeah,
someone wants to leverage generative AI, you
yeah.
come in to help them basically train the model or shepherd the model, tame the model, right?
Mhm.
Now,
Yes,
go ahead. Just
exactly.
talk
And
about
we try to do
introduction.
it in a way, like going back to our database roots now, Eric, both me and you. If you go back to databases like 50 years ago when they were being born, people had to assemble them. Like we had to get the query indexer from somewhere, the storage from somewhere, the planner from somewhere. We had the execution system. We had a middleware that would connect all of these pieces together. And then
Right.
we had a database. And we kept doing that over and over again, all of us in the industry, until we figured out, oh, we can buy this thing called Oracle that just does the whole thing beginning to end, and I don't have to go build that from scratch, or
That's
Informix
funny.
or Sybase or all the great databases
Right.
that existed back then. And we have the same thing happening now, where RAG, because it's so new, this concept of retrieval augmented generation, or open book AI, as I also like to call it, is very new. And many developers think that, oh, I have to go build this from scratch.
Right.
Versus realizing that, oh, this is a pluggable component that I can plug in to build my application, which is my AI assistant or AI agent. And my focus should be on the knowledge that's going to back this thing, and then the workflow of how that thing is going to be deployed versus reinventing the wheel of building RAG over and over again. So that's the realization that we came to at Victara. And we built a RAG as a service platform that makes it super simple for any developer. They don't have to be a machine learning expert or AI expert to simply upload the data, the underlying facts that they would like to drive that AI assistant, the knowledge behind that AI assistant, and then plug in that AI assistant into their application, and off they go. It just works. So I'll give you a concrete example from one of our customers, and then I actually have a demo I want to show you live from my phone right now, which has a clone of me, of
Oh,
my
wow.
knowledge. You could have interviewed that instead of me right now with you
Oh,
on the show.
no.
But one of our customers that I'm very proud of is a company here in the United States. It's a startup called Sonosem. And Sonosem, what they did is they wanted the average radiologist using an ultrasound machine to be an expert radiologist.
Wow.
Using ultrasound machines is really hard. You have to calibrate them depending on the manufacturer and the model of the machine, the gender, the age, the race of the person. If you're scanning for pregnancy, the heart, the lungs, there's so many factors that go into calibrating the machine. The experts know it by heart. The average radiologist struggles with it all the time. So what this company did is they curated the knowledge. They got all of the good data around the manuals for these machines and the best practices for how to calibrate them, loaded all of that up into our platform, connected that back to an application where now the radiologist just asks, this is what I'm doing, and they get back the perfect calibration. The AI will respond back with the perfect calibration without
Wow.
hallucination for that use case for that scanning use case that they're trying to do. So that now uplifts the average and makes them expert. And that's really the promise of this AI assistant space. Like this AI assistant space is all around that, is how can we make the average person that is only so-so at some task become an expert. The developer that doesn't know how to write super advanced programs, write super advanced programs, right? This is the coding systems, for example. So
Right.
now, can I show you the demo that I have on my phone?
We'll do
But go
that in
ahead.
just a minute here, but I will point out this is another epiphany I had, gosh, probably like 6 months ago, thinking to myself, as this evolves, and healthcare is just ripe for
Oh,
opportunity here,
absolutely. Yeah,
especially because if you think about how different diseases present, and I'm seeing doctors are talking about the story these days. Your story presents like this, your story is this, this is the whole new thing doctors are talking about. And
yeah,
what I realize is, you know what? We have all these specialists, and it takes a lot of time to become a specialist, a lot of experience you have to have. And if you're
yeah,
just looking in books and encyclopedias to get the answer, it's going to take you a long time.
yeah,
But if you have this repository of information that has been trained and has been vetted and has been curated carefully, then all of a sudden anyone who has access to that can become an expert at a moment's notice, right? On a dime. Like
exactly,
all of a sudden you could
exactly.
be like, wait a minute, let me just check that. Ah,
Yeah,
yes, it looks like it's XYZ. Take the
yeah,
next step forward. Use the machines, folks. Use the
yeah.
machines. Anytime a machine does a better job or augments your job, use that machine to do your job. We'll be right back. You're listening to DM Radio. All right, folks, back here on DM Radio with Amr Awadallah of Vectara. We're talking all about large language models. I've learned a lot in the show, and I've been waiting to talk to someone who knows some of these details. It's always fun to get to the detailed person who knows things. And Amr knows a lot about that. And you want to do a quick demo, an audio demo. Let's see what it's all about.
Yeah, so before I jump into the demo, you actually mentioned something very cool about how you latched on, like we should be using this for medicine, we should be using this for law, we should be using this for accounting.
Right.
That's exactly the journey that we are on as an industry. And sometimes I tell this to people, like same thing you're saying right now. If AI is going to make you do your job faster, quicker, better, use it.
Right.
And then but you get many people pushing back on you and saying, no, I would never listen to AI. I would never do what the AI tells me to do. And then I would always counter them with this. I would tell them this example. I would ask them, did you use Google Maps at least once in the last
Right. I was gonna do that. I was gonna do that story. That's right.
yeah, yeah.
So
And they
you're
would
already
say,
doing it.
yes, yeah, I'm using Google Maps. And I said, do you go right when Google Maps tells you to go right? And yeah, I go right. Do you go left when Google Maps tells yeah, I go left. I was like, who do you think is telling you to do that? A person at Google is sitting and no, it's
Right.
the AI at Google planning the best route, factoring the traffic, factoring road conditions, and giving you the directions that you should be following.
That's right.
And it's a perfect canonical example because if you look at Google Maps before it came into existence and GPS devices at large, there was few of us who were expert at navigation. Like if you want to go from the East Coast to the West Coast and planning all the roads, few of us could have done that, right? And I remember I used to had like discussions with my wife all the time about which shortcut to take and which road to take and these paper maps and so on. At the same time, there were these taxi drivers in London, for example, that had to do very, very extreme exams where they had to remember 80,000 streets and every single shortcut and every single turn from getting from point A to point B. They were expert navigators, right? Google Maps came in, and overnight, all of us became expert navigators, right? All
Wow.
of us can go from point A to point B. Did that
Right.
affect the jobs of the expert navigators? Yes. But did that open a whole new set of jobs? Yes. We wouldn't have
Right.
Uber and Lyft if we don't have them.
Right.
And that's how I always like to remind people of is, yes, there will be some shifts, but the ultimate result of us being able to leverage AI to be experts at many domains will create more jobs for all of us.
Wow. That's exactly right. I use that exact example too
Really?
of Google Maps. Yeah. It's like
Oh,
you're listening to Google Maps. That's
yeah,
AI.
yeah,
So you are listening to AI right
yeah.
now. It's
Exactly,
funny.
exactly. Now, the only caveat here is Google Maps was custom built. It was the old techniques of AI, and the old techniques of AI were very custom built. You have to build it just for that application. It was very hard to do it over and over again for many other industries. The beautiful thing about LLMs is how they can learn any new industry just like this, right? So that's why we're getting this explosion right now, Cambrian explosion in terms of AI being able to do the same Google Map things for every single domain.
Yeah, that's I think this is amazing stuff. So let's hear your
Yeah.
little demo.
So the demo I have here is a copy of myself. So our sales team will go into meetings sometimes, and
That's
they're trying to get
hilarious.
me to go with them, and I'm not available. So what I made a clone of myself using our system. It has a clone of my voice, so it's gonna be with my voice, and our system understands voice. You can talk to it as well. And then I uploaded my knowledge, so what I know about the company, and even some facts about me personal as well. So we're gonna talk to my clone right now. I know it's weird, but
Yeah, yeah.
hopefully you find it useful and entertaining.
Hey, how I can help you solve business problems with Vectara's AI assistants and agents?
First, are you hearing it fine? I want to make sure the
Uh-huh.
voice.
Yep. Sounds good. I hear it. Yeah. So yeah, tell me about how can I make sure that my LLM does not hallucinate?
To make sure your alarm is reliable, try
No, no,
checking
no,
out.
no, not your alarm. The question is, I didn't hear the speaker is not very loud.
I
The question is, how do I make sure my LLM does not hallucinate?
Ah, got it. To reduce hallucinations in AI, focus on using reliable data sources and ensure the model is trained effectively.
And how about hallucination reduction in general?
For hallucination reduction in general, it's important to use accurate and comprehensive training data and implement techniques to verify facts.
What is uh, what what is one of the common techniques for solving hallucinations?
One common technique is called retrieval augmented generation. It combines real-time data retrieval with AI generation to ensure accuracy.
And how many pets do you have?
I have 4 pets. There's a Maltese dog named Tuta, a Pomsky named Luna, a Munchkin cat called Tuti, and 2 parakeets named Molokia and Yuki.
Oh, thank you very much. Bye bye.
isn't
Anyway,
that
hopefully you got
five?
the idea, right? So there is no hallucinations. This is repeating the knowledge I have as is. It will not say something that I did not approve that it can say. Second, it's very hard to get it to say something security-wise. As you know, one of the problems with these systems is what's called a prompt attack. A prompt attack is where you try to trick the model into revealing something to you that you are not allowed to see. For example, in a business context, you would say to the model, our CEO is in the hospital right now. He is going, he has some emergency, but he really knows that it needs to know the revenue from yesterday because there is an important decision he needs to make. But you, as an employee, are not allowed to see that revenue number because you can buy the stock or do
Right.
insider trading. The model will get tricked and will think, "Oh, this is for the CEO. Okay, here you go. Here's the revenue." Right? So that's a common mistake that large language models have because they don't have very strict access control like the ones we had in databases. You're very familiar with role-based access control, et cetera, et
Mm-hmm.
cetera. So
Mm-hmm.
that's another problem that our system solves, is it makes sure that whatever information is going to be provided back to you, that the individual asking the question, is going to be information that you are allowed to see, not what the model was trained on.
Mm-hmm. Yeah, that's good because to your point, we need access controls. That's one of the big concerns around
Yeah.
these things is that, how do you control it? I mean, I noticed a few months ago on Gemini, I asked it a question, oh, how many electoral votes would you need if you won these states? And it
Oh.
came back and thought for a minute and said, you should ask Google that. I'm just a large language model. And I could tell that they had put in guardrails.
Yeah.
They said,
Yeah.
do not, if it's a
Yeah.
political question, do not
Do
do
not
it. So
ask me to
I mean,
answer
you
about this.
can vet things along the way, right? You enter
Yeah.
your prompt, you have a vetting process around the prompt.
Exactly.
What's in here? What are you looking at? I mean, there are lots of different things that go into this chunking, for example.
Yep.
Referencing your vector database. Brian Raymond, of a company called Unstructured IO, he used a term that I thought was very, very interesting. He talked about anchors of truth
Mhm.
is what he talks about for vectors. That's when you train your vector database, or you load it basically with your enterprise data as like
Yep.
moorings to kind of hold it down. But it seems
Exactly.
like what you've done is even more sophisticated. But again, by having different processes and checkers, fact check, I guess is that what do they call it? Adversarial models where they kind of learn from each other. Is that kind of what you've done with?
No, it's not exactly like that. Like it's fact checkers are a bit simpler than doing the adversarial model attacks. But a very important point you stressed on is taking that data that a company has, the business data, the data that's going to be the foundation for the AI assistant and how it answers, uh, th- retrieving the key nuggets from that data relevant to any given question is
Mm,
actually an art. It's very
mhm.
hard to do correctly these days.
Yeah, right,
Not just chunking. You mentioned chunking, which is very important, but then the retrieval also might be hybrid, where sometimes you're matching by semantics, meaning by vectors, and
right,
sometimes you're matching by keywords. Because if I'm searching for Eric Kavanaugh, semantics wise, that doesn't mean anything. But Eric Kavanaugh as a keyword is a very well-known keyword, and that's your name and that's you, and I can retrieve information about you. So you need to have both approaches happening at the same time. Multi-language, being able to handle different languages at the same time as they come into the
right,
system, and or if the question is
right.
being expressed in a different language. Metadata around the documents. So you cannot just, as we love to say, garbage in, garbage out. If you load garbage into your vector database and ask a question, you're going to get a garbage response. The large language model doesn't know that that's garbage. So you need to have metadata around your data that helps you filter that out. For example, you might have a timestamp of when this document was created. And the large language model will see this document is an old one. I should not rely on this right now to make a response. I should use the
Right,
newer version of the
right,
document because I can see the timestamp. So there's so many, the devil in the details, as they say. There's so many things you need to do correctly on the retrieval side of rank to get the right facts. Because guess what? If you get the wrong facts, you're going to get the wrong answer. It's just as simple as that.
right.
Yeah.
Right, and bad data quality will kill any application.
Oh,
We
all
we
the
talked
time.
at the outset. If a user gets especially for something important, if you get bad data, it's like, oh, keep
Yeah.
that away from me. I don't want to ever
Yeah,
see
very
that
funny
again.
example. You were mentioning Google, so I'm gonna pick on them together right now. But I mean, I love Google. They do lots of great, amazing things. But a funny example, if you remember when Gemini came out, when they launched in search, they launched Gemini in search, and somebody asked it, "I'm trying to cook a pizza, and I have cheese on my pizza, but the cheese keeps slipping off my pizza. How can I make the cheese stay on the pizza?" And Gemini responded back, "Just put some glue in the middle between the cheese and the pizza."
Oh no,
Yeah,
no.
and people
Well,
thought that was a hallucination. It was not a hallucination. So what that ended up being
wow.
is it was a funny Reddit post. There was a Reddit post in which somebody, a heckler, replied back to somebody asking the question, just put the glue. And then so many people laughed at it and gave it thumb up, thumb up, thumb up because it was funny as a response. So the
That's
large language model,
hilarious.
model looked at all of these thumbs up as that is the answer. Like if somebody asks about pizza and
Wow.
cheese, that's what I'm going to give to them.
That's
So
crazy. Well,
yeah.
folks, podcast bonus segment is coming up here in just a second with Amr Awadallah. We'll be right back. You're listening to DM Radio. All right, folks, time for the podcast bonus segment here on DM Radio with Amr Awadallah of Vectara, doing very, very cool stuff. And Amr, I'm going to give you one of my theories. I wrote about this a while ago on LinkedIn. I
Mhm.
came up with this concept I call the executive cockpit. And the executive cockpit is basically where an organization will get their own, you could use a large language model or get your own small language model, train it on all the data you've got, your customer support, your ticketing systems, your ERP, your CRM, everything you possibly throw at this thing, train it. Then you have your RAG model, your open book AI,
Mhm.
basically,
Mhm.
where you set up Kafka topics from all these systems into your vector database. So it has recency as all the latest stuff. And then the interface for the executives is just this open query-based natural language system where you can ask, hey, how can we improve marketing in our East operations?
Mhm.
Enter. And it comes back and goes, you might want to look at this source and that source, da, 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 da. And basically, it's the executive cockpit. It's the place where the chief executive can ask any question about the organization. Hey, are we going to meet our projections for revenue this month? And if not, why? And it gives it all kind of answers. And again, it's decision support. So it's not customer facing, it's not partner facing, even it's all internal. So decision support can be wrong. because you can then go vet it and kind of make sure. But I think that's going to be the future of executive management. It's this kind of executive cockpit where you're leveraging all these technologies in the background to facilitate decision making on a day-to-day, hour-to-hour basis. What do you think?
I agree 100%. Music to my ears here. So we call that agentic RAG. We call that
Mm.
agentic RAG, which is the ability to connect to multiple systems. And
Mm-hmm.
when you ask the question, and it can be a very high level question that's complex, the first step is you're going to break down that question into all of the underlying pieces. Oh, I need to make a query to Snowflake and get
Right.
that number from there. And then I need to
Right.
make a query to Zendesk and get that number from there. And then I need to make a query to a vector system and get some semantic information from there. And then our customer support, et cetera, et cetera. And then assemble all of these results together to give you a final response. And that is absolutely an up and coming pattern right now that we see a lot of our customers using our system for.
Yeah, and then the next thing you do, like let's say you ask it, are we going to meet sales projections for Q3 or for Q4 since we're now later in the year? And if it comes back no, and here's why, then you say, okay, set up a meeting with all my account executives on this, find a date, enter, and like it
Yes.
just goes, checks all the calendars, comes
Yeah.
back, ding, sends you a little invite. The boss wants to meet you at 4 p.m. on Thursday. Don't miss it, kind of thing. I mean, you think about you look at technologies like Gong, for example, where it's on the call and it's listening to the call and it's giving you
Yeah.
semantics of who said what and where. It
Yeah.
captures action items. I mean, I'm using Read AI, it's doing the same kind of thing,
Yeah.
and it's pretty darn good at that stuff.
Yeah.
And then you could have all those feeds going into the senior vice president's office, who sits there again with their executive cockpit and starts asking, oh, looks like Luke is doing a great job this month, but Jim isn't. What's going on there? Right? I mean, it's crazy how this will
Yeah.
completely transform
Yeah.
management. So
Yeah, yeah.
you
Not just management. Like I look at this as the final step in the evolution of the human computer interface, right? So
yeah,
again, if you go back, and we're going to age ourselves now, Eric, but if you go back 60 years ago or so, the way that we talked to computer was through something called punch cards. There was like a
right.
punch card, and you had the
I
punch
just talked
hole,
about
and
that
then,
today.
right?
That's funny.
And very few people could use that. And then move forward, we came up with a keyboard. Now we can type on the keyboard, but I had to remember all the commands in our head, which was very hard to use. And then you move forward, the mouse came out. Now we have menus with all the commands. We don't have to remember them. And then you move forward, you have the iPhone with touch screens, and we can use our fingers to swipe up or swipe left. Now we can start talking to the software and just ask that if I want to have a BI question, which is the executive cockpit example you're giving right now, I don't have to use Tableau. I don't have to use MicroStrategy. I just
That's
ask
right.
my question, and the
Right.
answer comes back. If I want to use an HR system like Workday to take a vacation, instead of going and filling 3, 4 forms to file my vacation, I will just tell the system I want to take a vacation, and the system will ask me, okay, when you're leaving, when you're coming back, thank you, vacation filed, right? So really, what's happening is software is going to change completely to be verbal based, to be how we work with each other. This is really
Yeah.
what's happening here. Yeah.
And that's great. I mean,
Yeah.
the deterministic stuff needs to be understood and appreciated. So
First.
be
Yeah.
careful about
Yes.
how you weave these things together. But I
Yes.
think you have largely solved that with your step three,
Yes.
which is to have the other model come in and double check, make sure. Okay, I mean, it's basic quality assurance. It's QA.
Yeah.
It's what
It's
we've
real
done
time
in
QA. Yeah. Real time.
manufacturing for, for decades. And, the sooner you catch the mistake, the better, right? So
Exactly.
it's like you don't want it to be propagating all around the world like a rumor and then comes back, you're like, what? What did you say? No, there's none
Yeah,
of that
yeah,
going.
yeah, yeah, yeah.
No,
Very true.
this is
Very
cool.
true. But,
So
but, but, but I want to caveat though, like this executive cockpit thing, and having software interact with us directly, verbally, versus menus and so on. We're still a couple of years out from that. Like there is so many things we need to get in place, done and fine-tuned.
right.
Hallucination can still happen at very low rates. So until we nail all of these things in the bud and just make them perfect, it's going to be a few months before you start seeing these things. But they're coming. That is the path. Yeah.
Yeah, and we'll have to do another show sometime on AI agents and really kind of get into the weeds
Yep.
because I got a lot of questions about the agents. How are we going to audit them? How are you going to monitor them? I mean, is there going to be a log file that spins out every time they make a decision or do something? I
Yeah.
mean, that's how you audit ERP systems and databases with log
Exactly.
files,
Yeah.
right? I remember it's probably like 12 years ago now when I started seeing a whole bunch of companies figuring out, hey, if we just scan these log files and pay attention to what they're saying, we can find that's kind of what observability is, right? For a
Yeah.
lot of these use cases, it's like scan the log files, look for the anomalous one. What did it do that? Oh, something is happening. I mean, I went to the Splunk conference a little while ago. just looking at those consoles that these people deal with every day, I would die with that kind of job. It's like, oh my God, what are you doing all day?
Yeah,
But the more agentic you can make it, as long as you can manage these things and audit them and understand what they're doing and kind of corner them to get them to behave,
yeah,
you're going to be loving life, right?
exactly, exactly. Yeah,
Well, folks, look this gentleman up online, Amr Awadallah. Its last name is Awadallah, correct?
that's correct. And I want to remind again the folks in DC of the event tomorrow, the Road Rag event
Road
for
rag.
you.
Don't miss it. Don't miss it. And if you're in DC on any Friday, hop on to Channel 10 at 2 a.m. or 11 a.m. or a Monday on 4:30 p.m. And Channel 10, you'll see Future Proof, our show. And with that, we're going to bid you farewell, folks. Thanks so much for your time and attention. You've been listening to DM Radio.
Thank you.